Good morning. Welcome back to Ground Floor, third in a series of talks on various exploitation techniques this morning. It's been pretty fun. As always, a few announcements before we begin. Live streaming is going on all day in this room, so please cell phones off. And if you have questions, if you wouldn't mind asking them at the microphone, so the internet can pick them up as well. I'd like to thank our sponsors, especially our Inner Circle sponsors, Critical Stack and Valamail. As well as stellar sponsors BlackBerry, Cylance, and Robinhood. It's their support as well as all of your participation that makes this thing possible. So please welcome Dimitri Fousekis.
Thanks. Okay, so we're going to be looking at low and slow techniques for DNS exfiltration. There's two things we're going to be looking at this afternoon about how to exfiltrate data from within an environment through DNS. And the main angle of the talk is regarding, for example, if you're in an assessment or you're trying to assess the security of a company or the ability to detect exfiltration through DNS, what are the other means you can use, or if there's some kind of system that's catching you out all the time, other options that you have to try and get data out of the company. So there's two sides to it. You can obviously look at it as a way from an offensive point of view to see how you can test the system's work. From a defensive point of view, you can figure out ways to try and combat what will be done if it's not already been handled. Just briefly, so we're not covering DNS tunneling of data in real time in and out, right? So this is not covering how you can get free Wi-Fi, okay? I think everyone knows that by now. So what we're more interested in is getting data out of an environment that is pretty well secured or pretty well locked down. We just don't have any other means of getting information out there, and you've also got the time to get that information out there. So kind of what the malware does, for example, if it's got time, low and slow as the talk goes, get that data out there and try and exfiltrate what can be done. Of course, ways to get around it. So currently, if we look at ways that data filtration can take place through DNS, there's the most common one, which is your DNS tunnels, as I mentioned before. There are many tools out there. If you just search for them, you'll find them. They tend to be easily picked up by most things out there these days that are looking for that kind of attack and that kind of exfiltration of data. Other ways of doing it, of course, is if you've got binary data, you could base64 that, use it in subdomains, and then pick them up on the other side as the DNS queries are being performed and convert them back into the data that you want. And the text records also very much a well-known attack as well. So what systems know, and by systems I mean anything out there from a product point of view that's trying to prevent DNS exfiltration, what they're doing pretty well is looking, for example, for abnormally long requests. Okay, so if they see a DNS request that look like their first line, well then you know there's something wrong. Large number of DNS requests from a single host. Okay, so you've got a desktop in the environment. It's pushing 200,000 plus DNS queries in the last few minutes. You know there's something wrong there. It shouldn't be doing that. The user's a workstation, no matter how much they're browsing and working on it. And another method commonly used as well is requests without dictionary words. So basically anything that is statistically doesn't sound like it would form part of a DNS query because it's not common language to us, right? It doesn't sound like it's a web server. It doesn't sound like it's a name. It's quite the entropy is quite high. The characters appear random. Of course, they aren't, but that's what they appear to if they're being analyzed. So that kind of stuff is also being looked at and detected. And then the other one that's also less common I've seen, I don't know if you've seen it more often, is systems capable of checking whether a DNS request was actually followed up by a connection to that IP that came back. Obviously, that requires a tie-in from various other systems and logs to correlate the fact that a DNS query was performed. Did I actually do something with that? Or have I looked up 10,000 A records or text records, and then didn't actually do anything after that. So we want to find ways to try and get around some of these, because they're pretty good at identifying whether we're trying to exfiltrate data out of the company. And we're going to have a look at 2 ways to try and accomplish that in this talk. So the first one is abusing trusted services within the environment. And the angle we're coming to for this one is that generally what we found is when looking for suspicious DNS information, DNS exfiltration, we tend to look at PCs that are doing too many DNS requests or strange ones. We tend to look at phones, bring your own devices, a printer, something like that. Something like an SMTP server, for example, though, wouldn't raise that much suspicion because its job is to do DNS lookups, right? So if you're in an environment and you come across an SMTP server, there's a very good chance that either no one's looking at what DNS queries it's doing, or it's on a whitelist of some kind when it comes to systems checking for DNS exfiltration. So how can we use it to exfiltrate data out of the environment? Now, we're not saying send mail through the SMTP server, because that's not really exfiltration, and you're going to show up in a log file a mile away anyway. What we want to do is get the SMTP server to send data out through DNS requests for us and stop there without actually doing anything further. And what's nice about SMTP servers, at least some of them, is that they verify a sender address when they're about to send a message or receive a message. So if you connect to the SMTP server port and you identify yourself, and then you say mail from, so if you look at the third box there, very common mail servers like Exim Synmail, there's the Oracle communication server, for example. When they see that, they will actually try and look up that domain to figure out whether it's valid or not as part of the verification. So what's happening is, from within the environment, you are now sending the data you want to exfiltrate to the SMTP server as a target email address. Then you stop there. That server went and looked up the DNS address because it thought, well, I need to do that as part of my verification. And at the same time went and connected outside, sent the query, and sent the data out that you wanted. So you could exfiltrate like that. And although you're going to show up in a log file, you generally will show up as connections or attempts to send mail that just didn't ever end. They timed out, basically. Because the key is not to obviously finish the SMTP transaction. You're sending just the mail from, the recipient to, and then you can cut the connection from there, because the SMTP server will already try and look up that domain and send the data out. So some servers that we found work by default to do this. They don't need specific customization. Exim Synmail and Postfix, an Oracle communication server. So if they're running in an environment and you want to get data out through DNS exfiltration, you can use this technique. We are going to put a tool up for it, but it's generally something you could develop on your own too. It's not difficult, because what you're doing is you're combining the old technique of taking the data in base 64 or any kind of method that you want, and we'll see in the next technique how to improve on that. But you're taking that, you're creating these email addresses and asking the server to send mail for them. He goes and looks it up, and out all those requests go for you and send your data out in the environment without actually sending any mail through it. We found by default Exchange didn't want to behave like this, so you might want to, if you have time, to play around with it and check why. I'm guessing it's because I think by default it's not set to verify the sender of the mail. So if it's being used as a relay, it will get to the point where it'll block itself as being used as a relay. But before that, it didn't try and actually verify the sender domain. The other ones, of course, they're doing that out the box. Issues with this technique? There's not many, because we have tried it in a few places, and we weren't picked up by common other tools that were detecting the attacks. Primarily because, as I mentioned, in quite a few administrators will whitelist SMTP servers from those checks because they're just doing so much work with DNS already. You are going to show up in log files if there's a tool performing that kind of analysis or someone knows what to look for. You are going to show up as a system connecting and performing almost half a correct transmission of email and then disappearing again. So if someone's looking at the logs files for that, you will see it. And then, of course, these other options that the verify sender option may be turned off, in which case this attack's not going to work because the mail server is not going to try and verify that domain when you try and connect to it. So, for example, how could we automate this? Well, what we could do is we say we've got, we've got sample credit card data, and we're using DNS to verify this SMTP server. I'm going to show you a demonstration. I'm hoping that the internet's going to play along for it, but as we know, it's could go anyway. So what I've got in the first window here is a server on the internet listening for DNS requests. Very, very simple. So that's obviously one of your major steps you need for exfiltrating DNS data is this DNS server you can control on the other side. Just want to get that command out quickly. Okay, so what we're doing on the bottom window, there's a little Python script there, and its job is to basically connect to the SMTP server. I'm using an example there of a credit card number. It's invalid, obviously, and what we're going to do is we want to convert that into, this is a very simple attack. We're going to convert it into a hex value. Then we're going to connect to the SMTP server and say, this is the mail from. Using the DNS exfiltration, we're going to have that hex value being part of the domain that we're using. And that's all we're going to do. And then we're going to disconnect. And what's going to happen is Synmail is going to try and verify that domain and inadvertently then also send out this data to the other side. So hopefully if everything plays along, we should be able to rebuild it externally. So let's see what happens. Let's go to the right directory. Again. Nope. That's what happens when you don't run your demos from the directory you were testing them in. Okay, that should hopefully work now. Okay, so very simply what it's done is it's just base64 the credit card number, and we've registered a test domain called greenkoala.ml, and that's what our bind server on the other side is listening for. So we want to tell Synmail that it's going to receive an email from Bob at that entire domain at the bottom there. So hopefully if all goes according to plan. Okay, so there. So he's sent the mail from command, sent it as that, and as you can see, immediately Synmail went and queried our DNS server for the actual sender to verify it, and then we got that, converted it back into normal data again. So obviously, things could still stop this, right? If there's something sitting on the other side of the SMTP server, checking whether, as I mentioned in the beginning, doing statistical checks on whether your DNS names make sense or not, yes, it would still pick this up. But generally, what we found is that SMTP servers are quite trusted. You can see them internally, and they tend to they can connect out quite easily, and no one seems to be watching what they're doing. So it's a good avenue. Play current slideshow. Okay, so then the second technique we're going to look at is to try and get past the other two checks that are out there. So request without the dictionary words, and also abnormally long requests. So how do we get around these two things? So if you look at the table below, it's quite obvious which one of those is trying to exfiltrate data if you were looking through log files, or if you were analyzing them. Whereas on the left, it looks more like general DNS queries that will be coming through your DNS server. So what we want to do is we set out to create a framework of sort that allows us to take this data that we want to exfiltrate through DNS and convert it into DNS queries that look like real-world DNS queries, and then push those out to our custom DNS server. Because what will happen then is that statistically we're still following things like there could be English words, they exist in a dictionary, they look like common system names, and so we can push data out like that. Now, the key thing here is that this is where the slow in low and slow comes in, because this is going to take a while, because obviously you haven't got much data to work with to send out in each of the queries. And as soon as you go too long, you're now passing the threshold from where statistically it's an English word or it's now too long and the entropy is too high. So how do we get around this? What we want to do is, so coming back to the same data that we had again, this credit card number, we take a table, and the framework I mentioned has a tool to do this. We take a list of words, common DNS words. You can find them anywhere. Alexa lists, top lists from search engines, custom DNS, anything you want. Obviously things that make sense. And we create a hex to common language table with them. So what we want to do is we want to take our data when it's in hex format and be able to get valid English words out of it, or common DNS names out of it, so that we can send those out and pick them up on the other side. What we do then is we convert the data to hex values, and then we dump DNS names to use. So once the tool is finished doing that, our credit card number, for example, will result in the following DNS lookups, which the system can use to exfiltrate that credit card number on the other side. And basically what we've done is very simple in its design, and you're welcome to make it more complicated. I'm sure there's many better ways of doing it, is we've taken that whole credit card number, so from CC until the 710, the CVV or the check number, we turned it into hex. And in our table, we're saying that for every single possible double character hex combination, give us an English word that is a common DNS name for it, right? The system does that, looks up in the table what those characters are, converts them to words, and then builds the actual names on the other side. So, for example, welcome4.mydom.coza, well, that's the one that actually represents those two characters, CC. Okay? So on the other end, when the tool runs, it loads the same dictionary and the same table up. And as these queries are coming in, it's now piecing it together and saying, okay, so I got welcome4, go welcome4, convert that back from the hex into text again, and so on and so forth. One caveat you will notice is that sometimes there's duplicates because we're using a table, so the same hex value is going to have the same name, so if it appears again, you're going to have the same query go out. So what you need to make sure and hope for is that the TTL on your DNS is very, very low, as low as you can possibly go, so they expire pretty quickly. Otherwise, he's not going to perform a lookup again, and what's going to happen is the receiver on the other end is going to be out of sync because he's not receiving the correct information on that side. The other thing to look out for as well, of course, is try and mix the domains. So we're building that into this framework as well. So you can register a pool of domains that your bind server will listen to on the other side. and it can randomly just change those, or it can use them for various things. So for example, welcome4.xyz.com, if xyz.com is being used and your bind server picks that up, that means it's the start of binary data. And then you can send the mydom domain or any other domain and end it with something else, .xyz.com, and that'll mark the end of the binary data. So that way you can build some kind of headers in so that when you're building the data on the other side, the system can make sense of what exactly it is receiving. Again, this is going to take it's going to take a while depending how fast you can push data out. So if you're doing this directly against the DNS server, yes, you can do it quite fast. If you're doing it through SMTP attack that we saw in the beginning, that's going to take a bit longer. You can generally fire off the request quite fast against the SMTP server. But again, you want to try and play under the radar of where detection tools are going to start figuring out that you're sending too many mails and too much data out of the company. The other thing to keep in mind as well is obviously use a dictionary. So the system just takes any word list as a dictionary, but it's got to be stuff that makes sense, right? So because statistical tools that are statistically analyzing DNS queries to look for DNS exfiltration are quite good. So, and with machine learning and things like that, they can be pretty good at understanding not just what's English and what's not, but what's commonly used on the web and what is not. You know, so if you plugged in a medical dictionary into the system, you might get detected because those kind of subdomains don't really appear everywhere on the net. So pick stuff. What I used here was I just looked on the internet for a list of common subdomains used for hosting environments because I figured that would be the most called. And then you can play around with that and get lists and things that work for you. So as mentioned, we'll put this framework up on GitHub soon. If you follow my Twitter account, you'll find the tools there. We're trying to build the framework up piece by piece at a time. So there'll be a tool to use SMTP exfiltration. There'll be a tool for common language DNS exfiltration, or CLDE as we call it. And of course, we want everyone to build on that and try and make it better. From a defense point of view, again, as I mentioned, there's various ways to pick up if this is happening in your environment. From an SMTP server perspective, you should probably be looking at what the logs are doing, the actual engine's logs, so that you can map DNS queries according to what the server was doing. And you may, if you're paying enough attention, or if your tools are adequate enough, which are analyzing that data, they'll see that these DNS queries that you were doing were coming from only half-sent messages. But again, it depends on the logging as well. We've seen some environments where to avoid the log files growing too big, if an SMTP message is not fully transmitted correctly or it's stopped, the server won't even log that at all. In which case, that's a field day for this kind of attack because you're never going to show up in a log file because you didn't finish the SMTP session. Other things we want to build into it, obviously, is to be able to do a TCP connect, so keep that in mind as well. I think there's one tool, I'm not remember its name, but I came across it, that is using machine learning for looking for various attacks. One of them is DNS exfiltration. And what it is doing is it's looking at DNS queries coming out of the environment versus connections going through the firewall or firewalls. So that kind of thing is something to look out for if you want to try and test if you're being nabbed. Again, though, some of this also is only, it's not really proactive, it's a reactive attack because you can send the data out and only next week when millions and millions of records have been processed, can somebody come to you and say, okay, something was up here that shouldn't have been up. But again, it is possible to do that. Okay, so I only had 27 minutes for this talk, so it's I'm not sure we're going to have enough time for questions, but maybe one or two very quick ones, if anyone has any. Okay, we'll start there. We'll start with Andrew at the mic, yeah.
Okay, the talk was awesome. Like, I really like the tool and stuff. Can't you use the SMTP server when you do the hello? Doesn't it look up what domain you're from? Because when you use that, then of the few places that log the SMTP like half cents to see if you're verifying addresses, then they won't surely log that because you haven't even started sending you've just said hello. Do
Yeah.
any of those servers also look at the?
Yeah, so
one?
that would work too. The reason I didn't put it in the talk is because it's not on by default in I think all of those servers,
Oh, really?
if I'm not
Okay.
mistaken. So you need to turn on its ability to do that.
Okay.
If it is on, yeah, that's great because right at the beginning, you can send the DNS query, the DNS exfiltration on the hello.
Yeah. Okay.
Cool, thanks. Else was there someone else?
I was just curious about the lookup table of words and stuff like that. Can you have the ability to have different lookup tables every 20 characters so that you get a much more random, or every five characters, so that you get a much more random distribution of domain names?
Yeah, you can. So you can extend it. Either you can make it as long or as short if you want. You can randomly select within the file. You can. It really just depends what you're plugging into it. So you can create exactly how you want that file to look when the system uses it to create that table.
I guess my thoughts was whether C was welcome. If C was after 20 characters, could it be a different DNS name altogether?
Yeah.
And still be
Oh, I see.
decoded?
Yeah. Okay. So you mean the actual
Lookup table changes.
You don't mean the
every-
subdomain. You mean the domain that's doing the exfiltration too on the other end.
Yeah.
Yeah. We currently don't have that built in, but we can look at doing that. Yeah. So it could do that. That's also a good idea as well. Okay. So that's the end of our time, fortunately. But my Twitter account's there if you want any more info.